innermost. So what is it? I differentiate this, what do I get? Anyone?
Cosine?
Very good, but it's cosine of sine times. I'm here now. When I differentiate this function, what do I get?
Would it be sine of cosine?
I differentiate sine and I get cosine of sine times. I'm finally differentiating the innermost, which is?
Cosine.
That's it. Notice that there is no addition or subtraction. This is just the product. Okay, I want to come back here for a second to e to the x prime. Basically, e to the x prime, it is e to the x, but I should also multiply here by natural log e. Why I don't? Because there is no need. Why? Because natural log e is
1.
That's it. However, when we differentiate any other base, not e, to x, we have to use the natural log a. If it's e, I don't need it. But other than that, it's a to the x times natural log a. So if we want to differentiate, for example, 5 to 2x prime, I have 5 to 2x times the inner function prime, which is 2, times, because this is not e, I have to multiply by natural log 5. Yes, I will put a 2 in front. 2 times 5 to 2x times natural log 5. But notice the difference. If the base is not e, I must multiply by natural log a, or that number, whatever that is. If it's 5, I have to multiply by natural log 5. Identical formula if I have a raised to a function, which I already did use it here. I didn't tell you that, but I want to write it. So if I have a raised to a function prime, it will be a raised to that function, of course, times the function prime, and also times natural log a. If this is e, then this gets dropped because it's 1. Any questions? Okay, so I would like to look at y equals x squared e to negative 1 over x first. And then we're going to choose a problem like that.
Sorry, can I see the last page?
Yes, of course. Any questions about the chain rule so far?
Okay, thank you.
Thank you. Okay, so obviously here we have the product rule. Function 1, function 2. So when I differentiate, how much is x squared prime?
2x.
Good. Times e to negative 1 over x, and then plus x squared times e to negative 1 over x times negative 1 over x prime. What did we say about this? We didn't. You can say, you forgot. No, I didn't. We differentiated this. So what is 1 over x prime equal to? We need to remember that. These are basic functions.
1 over x squared.
But negative, right? Correct. But because this one has a negative, that's why this becomes 1 over x squared. I agree. Good. So the only thing I can do is just simplify. The other thing that I highly recommend here is to notice that both functions, it's a sum of two functions, have e to negative 1 over x in common, which is very important for what follows in this course. And this is 2x plus what? Javan? 1. Very important. Okay, and I promised 1, and I see 1 in the old book that I have. I showed you. You can choose if you'd like. I can bring it to the camera if you want. You can choose. I want to choose this one, number 44 here. So let's see. So 44 is y equals 2 raised to the third power, which has power x squared. Oops. Yeah, it looks scary. It's not. Okay. You'll see in a moment how we address this. So first of all, I am asked to differentiate this function. And I say to myself, okay, let me take a look. So this is, any questions? This is 2 to a function prime, right? No problem. 2, and I copy the whole thing. 3x squared times. Now I have to differentiate this. So how do I differentiate 3 to x squared? So let's write it like that. 3 to x squared for now, prime. But not forget that I need to find or multiply by natural log 2. So let's do this again. So I have 2 to a function prime, which is 2 to that function, times the function whatever prime, times natural log 2. Now I have to deal with this. So I continue. 2 raised to 3 raised to x squared. And now how do I differentiate this? Well, it's 3 to a function prime. I have to copy it. 3 to x squared. I have to write times x squared prime. Times I have to copy natural log 2, but now I have to copy natural log 3. Because I differentiated 3 to x squared. And the final step is I have to differentiate this. And I get 2x. And I will put it in front. So it's 2x times 2 raised to 3 raised to x squared times 3 raised to x squared times natural log 2 times natural log 3. So this is the final answer. I think we had enough of this unless you want to choose something else. I want to look at an example, which many of you will probably get to in math. An example called differential equation. So this may be your first contact to a differential equation. What is a differential equation? It's an equation that has derivatives in it. And here is our example. The second derivative of y minus 4y prime plus y equals 0. So this is a type of differential equation. We are given the function y equals e raised to rx. So they're asking us to show that this function satisfies the differential equation. In other words, this function is a solution of this differential equation. What do we have to do first? What do you think?
Take the derivative of y equals e to the rx.
Of course, I have to find, I have this but I don't have this, and I don't have this to put them in. So y prime. Can anyone dictate y prime? Let's say Isaac. Anyone who hasn't talked yet, please.
Is it e to the power of x times r?
Excellent. Great. Good. What about the second derivative? And this can be written as r times e to rx. Can anyone give us the second derivative, please? Anyone who hasn't said anything yet? Trey, would you like to try?
Would it be r squared times e to the rx?
Excellent. Very good. So now what we have to do is show that hopefully this is 0. So the second derivative will be r squared times e to rx minus 4 r e to rx and plus e to rx equals 0. So we had minus 4 plus y equals 0. Okay. It says for what, oh, I'm sorry, my apologies. So it says for what value find r. Find r so that this function satisfies the equation. Okay, perfect. So everything is fine. It is r squared e to the rx minus 4 times r times e to rx plus e to rx. Perfect. Well, how do we solve such an equation? Any suggestions? Anyone?
Plug and chug.
No. We have to factor out e to rx, and then r squared minus 4r plus 1 equals 0. And we could say initially, we shouldn't, that e to rx is 0, but we know that that's never the graph of e to rx. It's either increasing on all its domain, it does not go below 0, or decreasing on all its domain, depending on r, does not go below 0. That's not going to happen. But the other option is r squared minus 4r plus 1 equals 0. Since it's not factorable, I will use the quadratic formula. Can anyone dictate the quadratic formula, please?
Minus b.
So it's negative b, which will be 4, right? Plus or minus the square root of 16 minus 4ac over 2a. So this will be 4 plus or minus 12, but that's 2 the square root of 3 divided by 2. So the square root of 12 is the square root of 4 times the square root of 3. Do not simplify crossing out, please. You have two options. You either factor out 2 and simplify, or you write 4 over 2 plus or minus 2 the square root of 3 over 2, and you simplify individually. So this is 2 plus or minus the square root of 3. So we will say for that function to be a solution of the differential equation, r could be either 2 plus the square root of 3 or 2 minus the square root of 3. And then it's guaranteed for the function, the given function, to be a solution of the quadratic equation, of the differential equation. Any questions? Okay, I am going to move on to 3.5, implicit differentiation. Implicit differentiation. Okay, what does that mean? So here's an example. If I have something like y cubed plus 2x squared y equals natural log y, if my life would depend on this, I would not be able to solve this equation for y. Well, I am still asked to find y prime. We're not going to use this notation for implicit differentiation. There's nothing wrong with it. We're going to use dy over dx. So I can still find an expression for dy over dx, although I cannot solve this equation for y. If I can solve the equation for y, like let's say I have 2x, I don't need anything. I will differentiate and I get 2. But whenever I do not have the function, or I cannot solve the equation for the function, I will use implicit differentiation, not direct differentiation, because I can't. I will still find an expression for dy over dx, but I will find it implicitly, not directly, because I don't have the function. So how do I do that? Now, I'm sure you remember, let me